There is a stretch of ocean along the eastern edge of North Carolina where the sea does not simply take ships, it erases them. For centuries, sailors gave it a name that carried both fear and resignation: the graveyard of the Atlantic. It is not a single storm, nor a single reef, nor a single mistake that explains it. It is a system, a convergence of shifting sandbars, violent currents, and unpredictable weather that has swallowed an estimated 50,000 vessels without distinction. Merchant ships, naval fleets, pirate sloops, steamers, and modern freighters all reduced to fragments beneath the same waters. At first glance, the coastline appears unremarkable. A long chain of narrow barrier islands known as the Outer Banks stretches into the Atlantic like a broken arm. But this fragile geography hides a structural danger. Beneath the surface lies a constantly moving seabed. Sandbars shift without warning. Channels that were safe yesterday become lethal today. Charts become outdated not over decades, but sometimes within a single season. And then there is the current. Flowing northward along the coast is the Gulf Stream, one of the most powerful ocean currents on Earth. Warm, fast, and relentless, it collides with colder waters moving south from the Arctic. The result is instability fog that appears without warning, storms that intensify faster than sailors can respond, and waves that break in chaotic, irregular patterns. Navigation here has never been a matter of skill alone. It is a negotiation with forces that do not remain consistent long enough to be understood. To early European explorers, this coastline presented an immediate contradiction. It offered access to the interior of North America, yet punished any attempt to approach it carelessly. Spanish ships in the 16th century were among the first to encounter its dangers. Laden with silver and gold from the Americas, they sailed north along the coast, following routes dictated by wind and current rather than choice. Many never reached Europe. Storms drove them onto unseen shoals. Hulls split open, cargo scattered across the seabed. These were not isolated incidents. They formed a pattern. By the 17th century, as English settlements expanded along the eastern seaboard, the region's reputation had already begun to solidify. Mariners spoke of it in practical terms, not superstition. The problem was not simply that ships wrecked here. It was that they wrecked here in ways that were difficult to predict, difficult to prevent, and often impossible to survive. A vessel could be sailing under clear skies, only to encounter a sudden squall that pushed it sideways into shallow water. Once grounded, the pounding surf would do the rest. Among the most dangerous areas was a region known as Cape Hatteras. Here, the coastline bends sharply, forcing ships to adjust their course while contending with strong crosscurrents. The seafloor rises abruptly, creating shoals that extend far beyond what the eye can see. Waves break not in orderly lines, but in intersecting patterns that destabilize even large vessels. It is a place where control can be lost gradually or all at once. Sailors learned to fear it not because it was dramatic, but because it was consistent. And yet, ships continued to come. Trade demanded it. The Atlantic was the central artery of an expanding global economy. Tobacco, sugar, timber, and enslaved people moved along these routes in vast quantities. Avoiding the region entirely was not practical. Instead, captains relied on experience, on incomplete charts, and on judgment calls made under pressure. Some succeeded. Many did not. Wrecks accumulated. Over time, the seabed along the Outer Banks became layered with history. Wooden hulls from the Age of Sail lay beside iron steamships from the 19th century. Cargoes remained preserved in shifting sands, barrels, cannons, personal belongings. Each wreck represented a specific moment, a decision made too late, a storm that arrived too quickly, a calculation that proved just slightly incorrect. But the graveyard of the Atlantic is not defined only by its past. Its danger did not end with the age of wooden ships. In the 20th century, even as navigation technology improved, the region continued to claim vessels. During World War II, German U-boats operated off the American coast, targeting Allied shipping lanes. The waters near North Carolina became an active war zone. Oil tankers and cargo ships were torpedoed within sight of land. Burning vessels illuminated the night, their silhouettes visible from the shore. Survivors who escaped the explosions still faced the same currents and surf that had claimed ships for centuries. The pattern repeated under different conditions. This is what defines the graveyard of the Atlantic. Not a single cause, but a continuity of risk. Technology changes. Ships become stronger, faster, more advanced. And yet, the underlying environment remains unstable. Sand shifts. Currents collide. Storms form. The system persists. Even today, modern vessels equipped with radar, GPS, and real-time weather data treat this stretch of ocean with caution. Shipping lanes are carefully plotted to avoid the most dangerous areas. Lighthouses, once the primary defense against disaster, have been supplemented by digital systems. But the margin for error has not disappeared. It has only been reduced, because the fundamental condition remains unchanged. The graveyard of the Atlantic is not a relic of the past. It is an active environment where history continues to accumulate beneath the surface. Each wreck adds to a record that is both archaeological and procedural, a long sequence of interactions between human intent and natural force. And that sequence raises a question that has never been fully answered. If the dangers of this coastline have been known for centuries, why have they never been completely overcome? Before continuing, consider this. How many of these disasters were truly unavoidable, and how many were the result of decisions made under pressure, incomplete information, or misplaced confidence? If the coastline itself created the conditions for disaster, then the ships that approached it revealed how those conditions turned into loss. The graveyard of the Atlantic did not claim vessels randomly. It exposed weaknesses of design, of navigation, and of judgment, often all at once. In the age of sail, a ship's survival depended on its ability to read wind, current, and depth without direct measurement. Charts existed, but along the coast of the Outer Banks, they were never fully reliable. Sandbars shifted too quickly. Channels opened and closed without notice. A captain could follow a chart precisely and still run aground, not because the chart was wrong when it was made, but because the environment had already changed. This created a specific type of risk: delayed error. A decision that seemed correct at noon could become fatal by evening. Consider the approach toward Cape Hatteras. Ships rounding this point were required to adjust course while compensating for lateral drift caused by the Gulf Stream. The current did not push evenly. It pulled at angles, sometimes strengthening without visible signs on the surface. A vessel that appeared to be holding its line could, in reality, be sliding gradually towards shallow water. The correction, when it came, was often too late. Anchoring offered limited protection. In heavy seas, anchors dragged. In shallow water, waves broke with enough force to turn a grounded ship sideways, exposing its hull to repeated impact. Once that happened, structural failure followed quickly. Timber cracked, seams opened, water entered faster than it could be removed. Survival shifted from navigation to escape, and escape was not guaranteed. The surf along this coastline is not a passive boundary, it is an active force. Waves break in irregular intervals, driven by intersecting currents and shifting depths. Lifeboats launched in these conditions frequently capsized before reaching open water. Those who attempted to swim faced undertow strong enough to pull even experienced sailors beneath the surface. This is why so many wrecks here resulted in total loss, not just of ships, but of crews. By the late 18th and early 19th centuries, the volume of maritime traffic had increased significantly. Trade routes intensified. Coastal shipping expanded. With it came a rise in recorded disasters. Insurance logs, naval reports, and port records began to reflect a consistent pattern, the same stretch of coastline appearing again and again under different circumstances with similar outcomes. It became clear that the problem was not episodic, it was systemic. Efforts to reduce the risk began to take shape. One of the earliest and most visible responses was the construction of lighthouses. Positioned along dangerous sections of the coast, they were designed to provide fixed reference point signals that remained constant even as the environment shifted. Among them, The lighthouse at Cape Hatteras became one of the most important navigational aids on the American coastline. But even this solution had limitations. A lighthouse could warn a ship that it was near danger. It could not tell the captain exactly where the danger had moved. Visibility itself was unreliable. Fog, formed by the collision of warm and cold air masses over the Gulf Stream, could obscure light entirely. At times, the warning existed but could not be seen. At other times, it appeared distorted, its position misjudged through layers of mist and refracted light. Technology introduced clarity, but not certainty. By the mid-19th century, another response emerged: organized rescue. The United States Life-Saving Service established stations along the Outer Banks, staffed by crews trained to respond to shipwrecks. Their role was not to prevent disasters, but to reduce their human cost. They operated under conditions that mirrored the dangers they were trying to mitigate, launching small boats into breaking surf, crossing unstable sandbars in darkness, reaching vessels that were already disintegrating under wave impact. Their success depended on timing, coordination, and a precise understanding of local conditions. Even then, outcomes were uncertain. What emerged over time was a layered defense system: charts, lighthouses, rescue stations. Each addressed part of the problem. None solved it entirely, because the underlying condition remained unchanged. The graveyard of the Atlantic was not dangerous because it lacked knowledge. It was dangerous because knowledge could not stabilize it. The coastline continued to move, currents continued to shift. Storms continued to form faster than responses could be organized. And within that environment, every ship that entered was forced into the same calculation. Not whether the route was safe, but whether it would remain safe long enough to survive it. By the early 20th century, the graveyard of the Atlantic had already accumulated centuries of wreckage, but what followed did not represent a decline in danger. It revealed something more precise. Even as ships became stronger, engines replaced sails, and navigation instruments improved, the pattern did not disappear. It adapted. Steel hulls resisted impacts that would have shattered wooden vessels. Steam power reduced dependence on wind. Wireless communication allowed ships to send distress signals across distance. On paper, these advancements should have reduced losses along the coast of the Outer Banks, but the environment imposed different limits. A steel ship that grounded on a shifting shoal did not always break apart immediately. Instead, it remained exposed, held in place while waves struck it repeatedly from changing angles. Stress accumulated across the hull, rivets loosened, plates bent. Failure, when it came, was delayed but not prevented. In some cases, this delay increased casualties. Crews stayed aboard longer, believing the vessel could still be saved, only to find themselves trapped when conditions worsened. Technology altered the timing of disaster, not its outcome. This became especially visible during World War I and more dramatically during World War II. The Atlantic coastline of the United States transformed into an active operational zone. Merchant ships carried fuel, equipment, and supplies critical to the war effort. Their routes, though adjusted for security, still passed near the same hazardous waters. German submarines' U-boats recognized this. They did not need to invent new dangers. They used existing ones. Operating off the coast of North Carolina, U-boats targeted vessels moving along predictable paths. The proximity to shore created a unique visual effect. When ships were torpedoed at night, burning oil illuminated the water. From land, observers could see silhouettes of ships on fire, their outlines sharply visible against the glow. It was a phenomenon later described as torpedo junction. But destruction did not end with the explosion. A torpedo strike disabled propulsion, damaged structural integrity, and often ignited cargo. Yet survivors who abandoned ship entered the same environment that had claimed vessels for centuries. Lifeboats drifted toward unstable shoals. Currents carried debris into breaking surf. Rescue operations, even when launched quickly, had to navigate the same shifting conditions. In this way, warfare intersected with geography. The result was a layered hazard. Human conflict increased the number of incidents, but natural forces continued to determine their final outcome. A ship might survive the initial attack, only to be driven aground hours later. Another might sink intact, its wreck preserved beneath shifting sands, inaccessible yet not entirely lost. Records from this period show a concentration of wrecks that is difficult to attribute to a single cause. Some were clearly the result of enemy action. Others were navigational failures. Many involved both damage compounded by environment. This complexity defines the modern phase of the graveyard of the Atlantic. After the wars, navigation technology advanced further. Radar systems allowed ships to detect obstacles beyond visual range. Electronic charts replaced static maps. Global positioning systems reduced uncertainty in location to a matter of meters rather than miles. Communication became instantaneous, and yet incidents did not disappear. Groundings still occurred. Storms still forced vessels off course. Mechanical failures still coincided with unfavorable conditions. The difference was statistical, not absolute. Losses became less frequent, but they did not reach zero because the core problem remained unresolved. The coastline continued to evolve. Barrier islands shifted position. Inlets opened and closed. Storms reshaped the seabed in ways that could not be fully mapped in real time. Data improved awareness, but it could not eliminate variability. This raises a more precise question. If modern systems can identify position, predict weather, and communicate instantly, why does the graveyard of the Atlantic still produce wrecks? The answer does not lie in a single failure. It lies in the interaction between systems that are precise and an environment that is not. Ships operate on calculated assumptions: course, speed, depth, timing. The coastline operates on continuous change. Where those two meet, a margin of error always exists, and in this region, that margin has rarely been forgiving. Beneath the waters of the graveyard of the Atlantic lies not a single layer of wreckage, but a stratified record of decisions. Each vessel rests where a calculation failed to hold, sometimes by meters, sometimes by minutes. Together, they form an underwater archive that extends from the age of sail to the present, preserved along the shifting seabed of the Outer Banks. Unlike deep ocean wrecks, many of these sites exist in relatively shallow water. This has two consequences. First, they are more accessible. Storms periodically uncover hulls that had been buried for decades, exposing ribs of timber or sections of iron to open water before covering them again. Second, they are less stable. The same forces that reveal them, waves, currents, and moving sand, also accelerate their decay. A wreck here is not fixed in time. It is continuously altered. Archaeologists working in this environment face a specific constraint. The subject of study does not remain unchanged long enough to be fully documented. A site mapped one season may look entirely different the next. Artifacts shift position. Structural elements collapse. Context, which is essential for interpretation, is gradually lost. This creates a paradox. The graveyard of the Atlantic contains one of the richest concentrations of maritime history, yet it is also one of the most difficult places to preserve it. Some wrecks, however, have persisted long enough to offer clearer insight. Among them is the USS Monitor, an ironclad warship that sank in 1862 during the American Civil War. Unlike earlier wooden vessels, its construction represented a transition in naval engineering: low profile, armored plating, and a rotating turret. When it went down off the coast of North Carolina, it carried with it not just a crew, but a technological shift. Its rediscovery in the 20th century demonstrated both the potential and the difficulty of underwater recovery. The wreck lay inverted, partially buried, its structure compromised by corrosion and pressure. Salvage operations required not only technical precision, but timing, working within narrow windows when weather and visibility allowed safe access. Even then, recovery was incomplete. What remained on the seabed continued to degrade, shaped by the same conditions that caused the sinking. The Monitor is not an isolated case. Dozens of known wrecks, and many more unidentified, exist along this coastline. Some are documented through sonar imaging. Others are known only through scattered debris or historical records that place them within a general area. In many cases, identification remains uncertain. A hull fragment may belong to one of several ships lost within the same decade. This uncertainty is not accidental. It reflects the density of loss. During certain periods, particularly in the 18th and 19th centuries, multiple ships could be wrecked along the same stretch of coast within a single storm. Their remains, broken apart and redistributed by currents, became intermingled. Over time, distinct events blurred into composite sites, archaeological layers that contain elements from different vessels, different voyages, and different moments. What emerges is less a series of isolated incidents and more a continuous field of debris. Efforts to manage and protect this field led to the designation of the Monitor National Marine Sanctuary, the first marine sanctuary established in the United States. Its purpose was not only to preserve a single wreck, but to acknowledge the broader historical significance of the region. Protection, however, does not imply control. Natural forces continue to operate without regard for boundaries or regulations. Divers who visit these sites often describe a consistent experience. Visibility shifts rapidly. Sand lifts from the seabed with minor disturbances, reducing clarity to near zero. Structures appear suddenly, then disappear again as conditions change. Navigation underwater becomes a matter of reference and memory rather than continuous sight. In this sense, the environment that challenged ships at the surface persists below it. The graveyard of the Atlantic is not simply a location where ships ended. It is a place where their remains continue to interact with the same system that destroyed them. Preservation and erosion occur simultaneously. Discovery and loss happen in parallel, and this leads to a final consideration. If the seabed itself is unstable, how much of this history has already disappeared before it could be recorded? In the end, the graveyard of the Atlantic is not defined by the number of ships it has taken, but by the pattern it continues to repeat. Across centuries, under different technologies and different flags, the same sequence emerges: approach, adjustment, uncertainty, and, in some cases, loss. The setting changes in detail, but not in structure. Modern shipping does not resemble the fleets that once struggled along the coast of the Outer Banks. Steel hulls are stronger, engines are more reliable. Navigation systems calculate position with precision that earlier sailors could not have imagined. Weather forecasts extend days in advance. Communication is immediate. On paper, the variables that once defined risk have been reduced, but they have not been eliminated. The coastline remains dynamic. Sandbars continue to shift, sometimes gradually, sometimes after a single storm. Channels that are safe in one season can narrow or disappear in the next. The Gulf Stream still carries warm water northward, meeting colder currents in unstable ways that generate fog, sudden storms, and irregular seas. These are not anomalies. They are baseline conditions. Modern systems respond to this instability by increasing awareness. Ships now operate with layered information: satellite data, radar imaging, electronic charts updated in near real time. Routes are planned to avoid the most hazardous zones. Margins of safety are calculated, monitored, and adjusted continuously. Yet every system depends on assumptions. Assumptions about timing, about accuracy, about how quickly conditions will change. When those assumptions hold, the system works. When they do not, the margin of error reappears, sometimes in subtle ways, sometimes all at once: a delayed course correction, a misinterpreted signal, a mechanical issue that coincides with deteriorating weather. None of these factors alone is necessarily catastrophic. Combined, they can be. This is why incidents still occur, not at the scale of earlier centuries, and not with the same frequency, but enough to confirm that the underlying environment has not been neutralized. Ships still run aground. Smaller vessels still capsize in breaking surf. Storms still push even well-equipped crews into situations where control becomes limited. The difference is not the absence of danger. It is the management of it. The graveyard of the Atlantic, then, is best understood not as a place of mystery, but as a place of consistency. It does not behave unpredictably in the sense of randomness. It behaves unpredictably in the sense of continuous change. Conditions evolve faster than they can be fixed into permanent knowledge. What is learned must be constantly revised. And this returns to the central question: If a system cannot be stabilized, can it ever be fully mastered? For centuries, sailors, engineers, and navigators have attempted to reduce the risks along this coastline. They have built lighthouses, developed charts, established rescue services, and deployed advanced technology. Each effort has improved outcomes. Each has saved lives, but none has ended the pattern. Beneath the surface, the record remains layer upon layer of hulls, cargo, and fragments, each marking a point where human intention met environmental force and failed to align. The graveyard of the Atlantic does not require a single explanation because it has never depended on one. It persists because the conditions that created it are still in motion. Thank you for watching this video. Click here to watch another video that might interest you.